This is PowerPoint Lecture 4 on the Introduction to Supply. Let's learn some economics. We're going to do very similar things to what we did with demand when we learned about the introduction to demand. Now you'll notice, first of all, from the law of supply. Now the law of supply, like the law of demand, is drawn from that assumption on rationality. Okay? It stands as a given from this that the supplier, like the demander, wants the most for the least, is the easiest way to say that. Rationality idea. Well, the most for the least is the highest price for the least amount. Okay? The higher the price you give them, the more they'll supply. That's the basic idea of the law of supply. And we see that phrase here. Now what this comes up with is exceptionally important. This means that the law of supply places supply in diametric opposition to demand. They are exact opposites. As a result of this, this makes our job a lot easier in terms of understanding economics, because we can employ now the logic of opposites. From the logic of opposites, it follows that if we know that two things are in diametric opposition to each other, whatever is true of the one, the other must be true of the other. Okay? We know what the law of demand says. Therefore, we know, since the law of supply is opposite, whatever we said of demand, the opposite must be true of supply. And we'll use this throughout. We'll see how this repeats itself throughout. And so in the law of supply, we have a positive correlation between price and quantity, where in the law of demand, we had a negative correlation. From this, we derive, as we did with demand, a supply schedule. Now, what this means is, on a weekly basis, given a certain price, and you see how this accurately models our law of supply. As price goes up, the supplier is willing to supply more units of the fish sandwiches. Okay, for $2, they'll supply 40 in a week. For $10, they'll supply 320 in a week. The more you give them, the more they'll be willing to supply. All right? Very similar. It's exactly the opposite of demand. As we did with demand, we can model this supply schedule in a supply curve. Now again, we are going to be dealing with a linear supply curve. In the upper levels of economics, microeconomics specifically, we'll deal with curvilinear and nonlinear functions of supply. Here, we're just building a baseline model, so we'll deal with only the linear version. And you see that this accurately models the demand schedule from the previous, or the supply schedule from the previous slide. At $2, they'll supply 40 units. At $4, they'll supply 115 units. It goes up for every $2, 75 units. Okay, and that's why we have this linear. Now, the other thing you'll notice that I want to mention about the supply curve, as I said, it's exactly opposite the demand curve. So while the demand curve was downward sloping, if you recall, our demand curve went like this, you see that our supply curve is upward sloping. This means that ultimately the slope of the curve will be positive. Now let's find, as we did with demand, a way of expressing this supply function as a linear equation. First, let's find the slope and intercept of the supply line. Now, what we know from the schedule and from the graph, from the line, we know that for every $2 change in price, the quantity supplied will change by 70 units. Does it not follow then that for every $1 change in price, it will change by 35 units? Okay, we know that it's going to be positive. For a $2 increase in price, they will supply 70 more units. For a $2 decrease in price, they will supply 70 fewer units, meaning that for $1, they'll supply 35 more. For a $1 drop in price, they'll supply 35 less. And so hence the slope is 2/70ths or 1/35th. And I know, I could feel it. I could feel you guys. I could feel you say 1/35th, and it kind of went through your spine. We'll take a look at how easy that is to deal with, and how we can deal with that. It's really not that difficult. Okay, now to find the intercept, we'll do what we did with when we were working with this with demand. Okay, substitute any two known values. Any two known values. Now that we know the slope, we substitute any two known values. Okay, let's use a price of $2 and a quantity supplied of 40 units. Okay, check your supply schedule, and you'll see that that's actually the lowest price quantity, right? Okay, so for $2 they'll supply 40. We then just simply do some math, and that will mean that 2 equals the intercept plus 40/35. Okay, we'll convert 2, because now what we're going to have to do is we're going to have to bring, and this is not really a math course, but we'll just go through the math real quickly. We bring this 40, we isolate the variable. Remember I said this is what I like about algebra, is it's about isolation, neutralization, and elimination. We bring the 40/35 over here to this side of the expression, leaving a all by itself. When we do that, it's going to change the coefficient to a negative number, and so it's going to be negative 40/35. Well, in order to add that 2 and negative 40/35 together, we need to convert 2 into terms of 35ths. Okay, well, 2 is the same as 70/35. This is the same number. This is two different ways of expressing the same number. Okay, that makes it easier. That means that what we're going to end up with is 30/35, which is 6/7. Okay, so this A is going to be 6/7. Now, as I said before, I like using fractions. However, we have to keep our eye on the ball. Always remember, don't get lost in just the mathematics and just solving the mathematics. We have to keep in mind what it is we're going for here. What are we going for? We're going to find the intercept. What is the intercept? Well, the intercept is the price at which the supplier will be willing to provide 0. Quantity is 0 at that point. Okay? Well, the supplier, as a result of this, the intercept will ultimately be expressed in terms of a dollar amount. Okay? Which means that we have to figure out how many dollars 6/7 of a dollar is. And it works out to be approximately 86 cents. We lose a little bit of our accuracy here, but not that much. It works out, it's in the hundreds. We lose about 1,000th of a dollar, but 86 cents. Okay? Now, be wary. I'm gonna encourage you to the best of my ability that when we start to use this expression to figure things out, okay, to discover things about supply and how supply works, I caution you against replacing the 6/7 with 0.86, because you're going to lose some accuracy. And when you lose that accuracy, it's ultimately going to translate into a loss of accuracy in your final conclusion. Okay? Now that we have the linear expression, let's play with it a little bit. Okay, what we've just figured out gives us this expression. Okay, P equals 6/7 plus 1/35 Q. All right. Remember, when we deal with P, we're always dealing with dollars and cents. I suppose we don't have to deal with dollars and cents. We could deal with euro or yen or whatever, but we're dealing with dollars and cents for now. Okay. Now, for the inverse, we'll find it the same way we found the inverse of the demand function. Okay. We switch the dependent variable to Q. We switch the placement of P and Q, which means we throw Q over to this side of the expression, which will change its sign and make it negative 1/35 Q. We throw P over to this side of the expression and make it negative P. So negative 1/35 Q equals 6/7 minus P. Okay? We multiply both sides of the expression by 35. Whatever you do to one side of the expression, you do the same thing to the other side of the expression, and it becomes the same expression. It's just another way of phrasing it. So that's the other way of phrasing that is multiply everything through by 35, and you'll have negative Q equals 30 minus 35P. Okay? Now, we multiply everything through by -1 to get rid of that negative sign in front of the Q, and we end up with Q equals 35P minus 30. Okay? To check this, we can simply substitute any two known values for price and quantity from the supply schedule in line to check that the statement is true. I picked right here, I picked 250. No reason you can pick any two numbers you want. You can pick any price and quantity you want to check and see if it's true. Okay, I picked a quantity of 250, which I put down here. The antecedent price for that from the supply schedule is $8, so I put that in for P, and I end up with 250 equals 35 times 8 minus 30. Is this statement true? In point of fact, this statement is true. And so our function is correct. Now that we know that it's correct, now that we know what we're doing with it, let's have some fun and figure some things out about supply and play with some problems. See, this is the fun of economics to me. I know that makes me kind of geeky, but we just have to know a little bit of mathematics, just a little bit of algebra, okay? And then we can start having fun with how we change price and what that's going to do with supply, etc., etc., etc. So let's move on to that. Let's look at a sample problem. And you know what we'll do? We'll borrow from the previous lecture. Okay, if you remember from lecture 3, where we figured out the demand function and all that good stuff, the question that I asked you in the problem was, all right, well, how much is going to be demanded, okay, if we set price equal to $7.50? Well, let's reverse that now. Let's say, how much will the restaurant, okay, how much will the producer be willing to supply for $7.50? And you see, I say that here. This is what we figured out last time. For $7.50, we figured out that demand would be 135 units. Confirm that if you want to. Go back to the previous lecture. Just look at the slides from the previous lecture, which you have, and you'll see that that's what we figured out if you can't remember. Okay? We figured out that for $7.50, demand will be 135 units. Question, of course, is what is supply going to be at this point at $7.50? To figure this out, we simply use the linear supply function that we just discovered in the last slide. P equals 6/7 plus 1/35 cubed. You can see what we're going to do here. Okay, and we'll do it in the next slide, but you can see what we're going to do. We're simply going to take this P and replace it. We're going to set the price at $7.50 and then do the math and figure out how much is going to be supplied. Let's do that now. Okay, we want to find out how much the producer would be willing to supply for $7.50. So we set the price at $7.50. 7.5 equals the intercept plus the slope times quantity. Okay, we move the intercept over. What we want to do, remember what we want to do in algebra, okay, always, and this is one of the things that, as I keep saying to you, that I love the most, is we isolate, neutralize, eliminate. Okay, I think of it as a military operation. We want to isolate quantity. How do we do that? We get the intercept over on the other side of the expression. Now, to do this, we move the intercept and change its sign. And that's scary, right? Oh my goodness! How do you subtract 6/7 from 7.5? Well, the way I chose to do it, and it's not the only way. Okay, there are other ways of dealing with this. I liked this way. This just intuitively came to me. In order to be able to add fractions, and ultimately this is a fraction, is it not? This is 7.5 over 1. That it's a fraction. Everything can be expressed as a fraction. This is 7.5 over 1. Okay? Well, in order to be able to add two fractions together, you have to find a common denominator. We'll use sevenths as a common denominator. So we have 6/7, which is our intercept, which we brought over. Question is, how many sevenths is 7.5? 52.5 sevenths. I know, it's something you haven't seen very much. You don't usually see that kind of thing in a fractional expression, but that's a perfectly reasonable way of expressing this number. 7.5 and 52.5 sevenths are the same number. They're exactly the same. Okay? And so this makes it possible now for us to add these two things together. We add them together, 52.5 over sevenths plus a negative 6/7, okay, minus 6/7, is 46.5 divided by 7. You know, that's one of the things that I was talking with a student the other day that was, oh, I can't stand math. It helps with math to remember that there are only two mathematical functions, okay? There is addition and there is multiplication. Division is simply multiplication by a fraction. Okay? And subtraction is simply addition of a negative number. Okay? That makes it a lot simpler. We're adding a negative number. So 52.57 minus 6 sevenths is 46.57 equals 1/35 cubed. Now we've got to find a common denominator. Well, just from eyeballing it. Now we can't always eyeball it, but this is fairly simple. Just from eyeballing it, we have a common denominator here, do we not? 7 is a common denominator. Okay? We have 46.5. If we, for example, what we'll do here, technically, okay, multiply both sides of this equation by 7. And what do you get? Well, the 7 over here drops out. You're going to get 46.5. If you multiply this by 7, you get 46.5. If you multiply this by 7, okay, you'll get 1/5 cubed. Because you'll end up with 7/35 cubed, which is 1/5 cubed. Okay? Right? Do that a couple times. Walk through it. I understand. Math may not be our strong suit, but we want to be able to master this. So look at it a little bit. Okay? This means that 46.5 equals 1/5 the quantity. Multiply now, but that's multiplying, and this is the step before. This is where I say multiply both sides by 7. That's what we do up here. Okay? Now we multiply both sides here by 5. That's going to make the Q a whole number. We end up with 232.5 equals Q. Well, that's what we were looking for. Which means, okay, now we went through all this math right here. Okay, and what happens to students? I've seen it happen a lot. It happens to master's level students. They lose sight of what it is they're looking at. They get so thrilled with the fact that they've found the answer that they lose sight of what that answer means. What does that mean? That means that for $7.50, our supplier is willing to supply 232.5 units. All right? Simple enough. Now, this brings us to a problem, doesn't it? And this will be the second sample problem here, okay? Exactly what we've just said. For $7.50, the supplier will provide 232.5 fish sandwiches. I don't know how you want to think in your mind of half a sandwich, okay? Think of it as a small fish sandwich. Instead of 8 ounces, it's 4 ounces. Whatever. Doesn't matter, okay? Now, from Lecture 3, we deduced that for $7.50, our demanders are going to demand 135 units. That gives us a problem, doesn't it? Okay? At $7.50, as the restaurateur, we'll be willing to provide 232.5, but our customers will only demand 135. That's going to leave us with 97.5 too many sandwiches. How do we deal with this? Well, we're dealing in this lecture only with supply. So let's adjust supply. How do we need to adjust supply? We need to drop supply by 97.5 units, okay, so that our supplier is supplying as much as our consumer is demanding. So we need to drop it by 97.5 units. Let's go back to the law of supply. What does the law of supply say? Okay, the quantity supplied will drop if we drop the price. We need to drop supply by 97.5 units. Does it not therefore follow that we're going to have to drop the price? Question is, how much more will we have to drop that price so that the supplier is willing to supply 97.5 fewer units? Okay? We'll find that out presently. Now, there are a few things that we know going into this, okay, that we can kind of just intuitively or just eyeball. All right, what did we figure out with the supply function? We figured out that for every dollar change in price, you're going to have a 35 unit change in supply. Now think this through. We need to change supply. We need to drop it by 97.5 units. Okay? Well, let's think about this. If we dropped the price $2, that would drop the willingness of the supplier to supply 70 units, right? Can we figure that out? For every dollar change, there's a 35 unit change in supply. So if we dropped it $2, it would drop supply by 70 units. If we dropped it $3, it would drop supply by 105 units. Well, 97.5 is somewhere between 70 and 105. So we're going to have to drop that price somewhere between $2 and $3. Okay? We know this going in. We can just eyeball it and see that. That's just a guesstimate. We want to figure out precisely how much we have to drop it. We'll do that in the next slide. Okay? Hence, to figure out the proper price change. Now, remember what we did. Okay? There's a difference here, and I want to clarify it. Okay? We did this with demand. Remember, we did the same type of problem with demand. We're interested now in changing supply. We're interested, technically, in a movement along the supply curve. We're not interested at all in where supply equals 0. Okay? So we're not interested in the intercept at all. So we drop that out of our expression. All we're interested in here is the slope. Okay? So without the intercept, this is our supply function. Price equals 1/35 Q. Okay? That's movement along that line. Okay? Without reference to where that line is attached to the vertical axis. Does that make sense? I hope that makes sense. Okay? Now, Q has to be 97.5. That's what we need to drop supply. All right? Simple enough then. Price equals 1/35 times 97.5. That's 2.79. It's actually 97.5 35ths. Okay? That works out to be 2.79. Now, what does this mean? Again, we don't want to get lost in the math. What does this mean? This means that we need to drop the price by $2.79. If we drop the price by $2.79, the supplier, the restaurant, will be willing to supply 97.5 fewer fish sandwiches. Okay? You'll be moving down that supply curve. All right? And so we need supply to drop, so it must therefore be a reduction in price. If we reduce the price by $2.79, which is to say from $7.50 down to $4.71, the supplier will now only be willing to supply 135 sandwiches. Perfect. We're golden. Great. That's how many our demanders were willing to demand. But it's not good. Okay? Because we've changed the price. Okay? We've dropped the price by $2.79 down to $4.71. What does that mean? That means they're going to demand more. Okay? So how many will our customers demand now that we've dropped that? As the restaurateur, we're willing to supply we're willing to supply 97.5 fewer sandwiches. We're willing to supply now 135, which is what they demanded for $7.50. But now the price is $4.71. I know these bastard customers of mine. I know them. They're always looking for more for less. If I drop the price of my fish, they're going to come in droves and demand more. I know they are. Question is how much? Well, let's revisit Lecture 3. In Lecture 3, we calculated this as our demand function. Price equals 12 minus 1/30th Q. Okay? We just went through and changed the price again. We dropped the price down to $4.71. Why did we do that? Because at first, at a price of $7.50, the demanders, the customers, were willing to demand 135 sandwiches. But our producer was willing to supply 232.5. Meaning that there's too many sandwiches, 97.5 to be precise, too many sandwiches. So we dropped the price by $2.79 down to $4.71. That caused our supplier to be willing to supply 97.5 fewer sandwiches down to 135. The problem is that look at what happens to the demand. 471 equals 12 minus 1/30th Q. Okay? We do the math like we did before. We bring Q over here. We bring the 471 over here. 1/30th Q equals 7.29. We run through the math. And that means that the demanders, the customers, are now going to demand 218.7 sandwiches. The problem is that as the supplier, I'm only willing to supply 135. They now want 218.7. Okay? That creates a problem. Okay? If only there were some way we could figure out, there has to be a way to figure out At what price will the restaurateur and the customer, the supplier and the demander, the producer and the consumer, at what price will they both want the same quantity? At what price will the supplier be willing to supply exactly and precisely as much as the demander demands? Well, for those of you who are particularly clever, you've probably figured out how you can do that. You can find that precise location using these linear equations. We're not going to do that now. I'm going to tease you a bit with it, okay? We're going to hold off on that until we discuss the idea of equilibrium, because by definition, that's what equilibrium is. Equilibrium is where supplier and demander agree on price and quantity, okay? So we're going to hold that off for a few lectures. In the next lecture, we're going to go through at great length a little more detail of how demand functions. Then we're going to go into how supply functions. Then we'll deal with equilibrium and we'll find this out, okay? So yeah, this is what piques my interest, is there's got to be a way to do this, okay? So ultimately to me, and that's why I kind of like math, that's one of the things I like about economics, that's one of the things I like about that's what kind of floats my boat. I like problem solving. And my understanding is now, when I took the SATs way back when, they didn't have this section. In the SAT, when I took it, they had math and vocabulary. But when I did the graduate record examination, and my understanding is now SATs have the same thing, they have a section on abstract thought, on problem solving. Okay? A lot of people misunderstand this. Problem solving is really a matter of intelligence. The ability to solve problems, that's what intelligence is. And of all the things we at Robert Morris teach you, okay, the fact of the matter is that in whatever line of work you go into upon college graduation, the material and information that you learn in college is not actually going to be that relevant for you. You're not actually going to use it that much. But what you will use multiple times a day on a daily basis is the thinking process that we train you to be able to think, okay, to problem solve, okay? This is a problem. We're going to work on solving it. We've already done that. That's all these problems. Every week we're going to do a problem, okay? The final in here is problems. We're going to be problem solving. We want to problem solve all the time, okay? And as I said to you in the introductory video, okay, with all of the problems we work on in here, you have a week to work on them. There is no time constraint. You can come to them and come back to them. You can ask me questions about them. This is the most important part of this course, or any course, is being able to solve problems. Okay? So we want to train ourselves to be able to do that. And that, to me, is also where the fun of economics is. Now, with all of that, let's look at what it means to shift, and we'll go over at the very end of this lecture in great detail, as we did with demand, the distinction between movement along a line and shifting of the line. Okay, so like in that problem we just dealt with, we were moving along a supply line. We saw that for $7.50 they would supply, what was it, 232.5 sandwiches. We had to drop that by 97.5. So when we dropped the price, we moved down along this line until we hit that $4.71, 135 sandwiches. Okay? Now let's look at shifting the line. And you see what the difference is. A represents an increase in supply. What does that mean? That means let's hold the price constant. This is exactly the same thing we did with demand. If we hold the price constant, we'll have more supplied for that given price. You see, if we hold price constant here, we have a supply of here in QS1, our original supply. If we increase supply, And we'll go through how we increase supply in just a minute. We'll go through all the things that shift that curve. You see that for the same price, you're going to have more supplied. If we decrease supply, you see that for the same price, you're going to have less supplied. Now down here, I go through them. We'll go through them in detail. This is basically all the things that's going to cause that, but we'll go through them in detail in the next slides. Number one determinant of supply is cost of production. In fact, what we're going to find out is that supply curve that we just figured out, that supply function that we just figured out, that's actually the same as the cost curve. It's actually the variable cost curve. Okay, we're going to deal with costs in great detail when we get to the lengthy discussion of supply. And supply, what we're going to do in the next lecture is go through demand. The next two lectures will go through a more detailed analysis of how demand works. Then the two lectures after that, a more detailed analysis of how supply works. Well, when we do that, we're going to deal with costs at great length and what changes the cost of production, how the costs of production work, etc., etc., etc. Right now, I just want to introduce the idea, okay? And again, I want you to employ logic, okay? And we can really, this is really based on Aristotelian logic. I think I mentioned to you once before that Aristotelian logic is based on the idea that it is either A or not A. No other possibility exists, okay? It either is something or it is not something. Simple enough, right? Okay. Well, when it comes to costs, we have two basic types. We have variable costs, which change, and we have fixed costs, which do not change. There can be no third possibility. It either is a cost that can change, or it is a cost that will not change. Okay? Variable costs change based on the amount we produce, okay, based on quantity of supply. Fixed costs do not change based on quantity of supply. Now, to give you some examples of variable costs and fixed costs, okay, and I have a couple here from the production, but we face these all the time, okay? I'll give you an example of a variable cost. A variable cost is the gas. If I'm a commuter, either to work or to school, whatever, right? My gasoline cost is a variable cost. In other words, if I decide to blow off class one day and don't drive to school, that reduces my variable cost because I don't have to buy the gasoline that gets me there. Okay? If I'm an online student exclusively and I don't go on ground, I can stay at home. I don't have to pay that variable cost of gasoline. Okay? So that's variable costs, okay? Fixed costs don't vary. They stay the same. Examples of fixed costs: rent, mortgages, loan repayments, okay? A lot of you guys are going to be facing loan repayments. You get out of school, you've taken out student loans. That's a fixed cost, okay? With fixed costs, it reminds me of that scene. There's a scene in Goodfellas, okay, where Paulie becomes a silent partner to the guy in his restaurant, okay? Well, the way it works with fixed costs, okay, they don't want to hear excuses. Fixed costs, they don't want to hear excuses. They don't want to hear you're out of work. They don't want to hear you're getting less money. They don't want to hear any excuses. Pay me, pay me, pay me. That's all I care about, okay? When I got out of graduate school, I'd taken out some loans to get some extra money flowing in, okay? So I owed some student loans. Well, I didn't get a job right away, and so I couldn't meet my student loan payments, and so I sat there, trying to give them an excuse. They don't want to hear it. You've signed on. This is your fixed cost. This is a fixed cost, okay? You buy a car for my car payment on this cruise that I bought for my wife is $283 a month. They don't want to hear excuses. Every month on the same day, $283 is coming out of my account, period. Now, what I do, a lot of people, I do all my bill paying online, Okay, most people I think do that too. My mother, I mean, my mother's 78 years old, so she's 78 years old, so she actually sits down and writes out checks every month. There are very few people who do that anymore. I mean, I pay it all online, but I have two types of costs. I have variable costs and I have fixed costs. My variable costs, my gas bill, that's a variable cost. My electric bill, that's a variable cost. That will fluctuate month to month based on usage. Okay? Like I've had lower than normal gas costs this winter, and it's been a severe winter. We all know it's been a severe winter. The reason my gas costs have been lower is because I disciplined myself and I kept checking my wife. My wife and I play this game in the wintertime. I think most married couples do. My mother and father played this game where in the wintertime, my wife goes and turns the thermostat up, and then I go and turn the thermostat down. Okay, well, we disciplined ourselves that we kept that thermostat at 65 degrees, dead solid, all winter. And as a result, it dropped our variable cost. Okay, but the variable cost is going to fluctuate. Gas bills, electric bills, sometimes cable bills. That's why I went away from Verizon. I couldn't stand Verizon because every time I'd get my Verizon bill, it was a differing amount. It was like a floating target. They kept adding charges here and there and there. And so I got rid of Verizon. Verizon is the most evil corporation in the world, so I got rid of them, okay? Comcast is becoming just as bad. I'm getting really pissed at those guys. All right, but that's a variable cost. Fixed costs, okay? So my variable costs, to finish this off, my variable costs, I use Huntington Bank's bill pay feature, okay? I actually go in and I, say bill pay and pay them a certain amount. Now, my fixed costs, I have automatically deducted. Why? Because I know what they're going to be. They are fixed. They will be the same month after month after month after month with no fluctuation and no variation. Okay? That's a fixed cost. All right? Now, total costs then are simply your variable costs, the costs that fluctuate, plus fixed costs, the costs that don't fluctuate. That's going to equal your total cost. Okay? As cost goes up, supply goes down, and vice versa. Okay? So as costs go up, the supply curve is going to shift left. It's going to shift inward. As costs drop, the supply curve is going to shift outward. This is the basis of supply-side economics, which is one of the things we touch on in macroeconomics. We'll look at it a little here, but in macroeconomics, we spend some time on it. Other determinants of supply. Number of producers. This is probably the most intuitive of them when it comes to shifts in the supply curve. As the number of producers increases, okay, supply will increase, okay, and vice versa, okay. This is assuming, of course, that the producer is producing more than 0 units. And for them to actually be a producer in a market, they have to be, by definition, producing more than 0 units. Okay? So if they produce 1 unit, if they enter into a market and produce 1 unit, the supply curve will shift outward. Okay? Alternative production possibilities. Now, this is a little bit more difficult to understand, but it's not unthinkable. As more profitable production possibilities arise, production will shift out of the less profitable to the more profitable commodity. All right? Let's suppose, we'll go back real quick to our restaurant example with the fish sandwich. Fish sandwiches aren't the only thing that I'm going to produce. Okay? I'm going to produce other things in my kitchen. Now, let's suppose that for whatever reason, my customers prefer hamburgers, okay? Meaning that I'm going to make more money off it, okay? Well, because of that, I'm going to shift my supply out of fish sandwiches and into hamburgers, okay? Let's suppose, okay? Give me another example. Give me another reason from exactly the same example. Let's suppose that my purveyor of fish, okay, raises the price of codfish, okay? Well, if he raises the price of codfish, this means I'm going to make less money off each sandwich. Unless I raise the price, and if I raise the price of the sandwich, demand is going to drop anyways. Okay? So if I keep my price the same and he raises the cost of my fish, I'm going to make less money off every fish sandwich. Now let's suppose at the same time that my ground beef supplier drops the price of ground beef. Okay, I keep the price of that ground beef the same. He drops the price of it. I'm going to make more money. It's going to be more profitable. So I'm going to shift more of my production into hamburgers. Okay, we see this now in a more, I guess, example that we can identify with. Let's look at college. Well, let's look at college. College presents a whole host of alternative production possibilities. We refer to these as majors. Some people go into accounting, some people go into finance, some people go into psychology, some into history, some into engineering. Part of what drives that decision is how much profit we think we're going to make when we get into that field. The more profitable fields will attract more producers. Okay? You are a producer. You're going to produce something when you get out of college. Okay? It will be a form of labor. Most people, when they go to college, it's going to put them in the service industry. Whether they be, most of the guys I deal with are educators, okay, particularly primary ed, which is to say early childhood ed, what they call early childhood ed at Robert Morris. Okay? Most of my geographers are that. Okay? Well, they're going to be producers of education. Why do they go into that field when there are alternative production possibilities? I ask myself that question every day. No, in point of fact, there's basically, and you know this from personal experience, there's basically two reasons why people choose a field of study in college. Either one, because it's going to be profitable when they get out. I think this is what causes most accountants to do it. Or two, because it's something in which they have interest. I did what I did for the latter reason, because it's something in which I have interest. Don't make a lot of money. I'm adjunct faculty at Robert Morris, so I make even less money. Professors generally don't make much money, okay, in comparison to others. All right, but in terms of the alternative production possibilities, because when we deal with that, and we deal with the major we're taking in college, et cetera, what we're going to do for our career and our lives, there's more than just dollars and cents. There's also enjoyment and benefit gained. And I'll tell you what, the job that I have is the greatest job in the world. It's the greatest job in the world. Okay? I'll give you an example, just real quickly, why it's the greatest job in the world. Right now, as I record this lecture, I'm sitting here in my PJs on my couch watching my fish. Okay? How many jobs? I don't care what you're paid. How many jobs can you do that? But at any rate, all right. So that's alternative production possibilities. As more profitable production possibilities present themselves, they attract producers. Okay? This is why in the 90s, so many students studied computer science. This is why at the turn of the century, the turn of the 20th and 21st century, so many people went into nursing. This is why the nursing program at Robert Morris mushroomed, okay? Because it's a very lucrative field, all right? That's alternative production possibilities. We have an antecedent. If you remember when we talked about demand, we talked about future expectations, okay? We have the same thing with supply, and like the one with demand, it becomes a self-fulfilling prophecy. Now, let's look at the expectations of the suppliers and how that's going to shift the supply curve. Okay? The first expectation is future demand. If we expect demand will go up in the future, we will, okay, and we have this time lag variable. Okay? So if we expect demand will go up in the future at time t1, we'll increase supply now, time t0. Okay? Now what that's going to do is that's going to push the supply curve outward, which means that the price is going to drop. Because the price drops, that's going to increase demand. Give you an example. Okay? Right now, at this point in time, actually probably a month ago or so, the producers of beachwear, okay, clothing producers of beachwear, swimsuits, things like that, okay, shorts, all that kind of good stuff that you see on the beach, flip-flops, whatever you call it, right? Okay, they started to ratchet up supply. Why? Because they know that come April and May, demand for beachwear is going to go up because you're going into the summer. So they begin to ratchet up production actually in the winter. You always produce, as a producer, they generally produce in any given season for the next season. So in the winter, they're producing for spring. In the spring, they're producing for summer. In the summer, they're producing for fall. In the fall, they're producing for winter. Okay? Because they expect demand to go up. Now, what's going to happen is, as a result of the fact that they increase production at time T0, that's going to shift the supply curve outward, which will drop the price. And when it drops the price, demand will go up. So it becomes a self-fulfilling prophecy. Future prices. If we expect the price to increase in the future, okay, we'll increase supply now, and vice versa. This becomes a self-defeating prophecy. Okay? I expect that I'm going to get more for my product in the future. Okay? As a result of that, I'm going to increase its production now. That's going to shift the supply curve outward, which will have the effect of actually lowering the price. Future costs. If I expect costs to increase in the future, okay? And this is something we'll deal with again at great length when we deal with costs. Because why would I expect costs to go in the future? What, for example, if I hear every quarter of a year, the Federal Reserve Board makes a report on the status of the economy and the financial system of the United States. Let's suppose that they come up with their report that there's too much money supply, that the money supply is too large, and so as a result of that, they're gonna rein in the money supply. That means interest rates are going to go up. If interest rates are going to go up in the future, I'll borrow my money now while interest rates are still low. Okay? Simple example. This becomes a self-fulfilling prophecy. If the producer expects cost to increase in the future, the producer will decrease supply now. Okay? Well, when I decrease supply, that's going to pull the supply curve inward to the left, and that's going to decrease supply and increase the price. So again, it becomes kind of a self-fulfilling prophecy. A final note. On page 61 of the text discusses an additional determinant of supply curves and supply curve shifts, meaning government interaction, taxes, subsidies, also research and development technology. We could add regulations, government regulations to that. The fact is that all of that affects cost of production. Okay? All of these things impact cost of production. Okay? If you raise corporate taxes on producers, that's going to increase their cost of production. That'll shift the supply curve inward. If you drop taxes, okay, that will decrease the cost of production, shifting supply outward. If you do the same thing with regulation, if you increase the regulation on an industry, okay, that's going to increase the cost of production. Okay, so for example, just as a quick example, some years ago, okay, actually just at the turn of the 20th century, actually it wasn't at exactly the turn of the 20th century, they decided that food producers would have to put labels on all of their food products, okay, with the nutritional content and the caloric intake and the ingredients and et cetera, et cetera, et cetera. Okay, well, that increases cost of production. Why? Because I now have to put a label on. That label costs money. The machinery to print that label costs money. Okay? So that increases my cost of production. The more we regulate, the more it's going to increase cost of production. Okay? So again, all of these affect that. Technology is going to also shift the cost of production. If there is a technological improvement in the production process, okay, that's going to make it easier, more efficient, less costly to produce the product. Okay? And again, we can think of a very simple example. Think of the invention of the backhoe. Okay, it digs holes, right? That big machine that digs holes. Okay? That was a technological improvement that reduces my cost of production. Why? Well, let's suppose what I'm producing, let's say I'm a contractor, and what I produce is houses. Well, part of that is I got to dig a foundation. Well, before the backhoe, I had to dig it by hand with a shovel. All right? And so I'd have to have 10 guys on hand, all with shovels, digging a foundation. It would take me 2 or 3 days to dig that foundation. All right? They invent the backhoe. Now, I don't need those 10 guys, so I fire them all. That drops my cost of production. What it took those guys 2, 3 days to dig out, with a backhoe, I can dig that out in a couple of hours. I can do 2, 3 foundations in a day, okay, if I'm working hard at it. All right? That reduces my cost of production. That's technology. So these all manipulate cost of production. And so we kind of just lump them in with the general cost of production effect on supply curve. Now, the final note here, exactly as I did with demand, I want to be clear, and we want to have it clear in our mind, the distinction, and you see it in the slide here, the distinction between movements and shifts, all that we just discussed, is a shift of the supply curve. That's what's going to shift the supply curve in or out. That is different than movement along the supply curve. When we dealt a little earlier with the sample problem of too many fish sandwiches, too few fish sandwiches, we're going to adjust supply to change how many the supplier is willing to supply. That's all movement along a line. Why? Because we're only dealing with price and quantity. If we're only dealing with the variables of price and quantity, we're moving along a line. When we're dealing with these other variables we just introduced, cost of production, number of producers, alternative production possibilities, okay, future expectations, that shifts the line itself. All right? And I think that concludes this lecture.